Assalamualaikum warahmatullahi wabarakatuh. Now, I want to tell you about my resume, and the title is Aeration. Before that, let me introduce myself. My name is Zahra Maulani, and you can call me Zahra. My number is 2106-0311-0075, and I'm from Chemistry B. Aeration. Aeration is the process of adding air or oxygen in water by bringing water and air into close contact by providing fine bubbles of air and allowing it to rise through the water. Aeration is the addition of oxygen into the water so that the dissolved oxygen in the water is higher. In principle, aeration mixes water with air or other materials so that low oxygenated water is in contact with oxygen or air. Aeration includes physical processing because it prioritizes mechanization rather than biological element. Aeration is a treatment process where water is made into close contact with air with the aim of increasing the oxygen content in the water. With increasing oxygen, volatile substances such as hydrogen sulfide and methane that affect taste and odor can be removed. The carbon dioxide content in the water will decrease. Soluble minerals such as iron and manganese are oxidized to form deposits which can be removed by sedimentation and filtration. Aeration is the process of dissolved oxygen in water. Effectiveness of aeration depending on how large the surface of the water is in direct contact with the air. The main function of aeration is to dissolve oxygen into the water to increase the dissolved oxygen level in the water and release the dissolved gases in the water and to help stir the water. Aeration can be used to remove dissolved gases, oxidize iron and manganese in water, and reduce ammonia in water through the nitrification process. The aeration process is very important, especially in waste treatment where the biological treatment process utilize aerobic bacteria. Aerobic bacteria are a group of bacteria that absolutely require free oxygen for their metabolic processes. With sufficient oxygen available during biological process, the bacteria can work optimally. This will be beneficial in reducing the concentration of organic substances in the wastewater. Besides being required for the metabolic process of aerobic bacteria, the presence of oxygen is also useful for the process of oxidizing chemical compounds in wastewater and for eliminating others. The aeration process is a process that functions the increase to solubility of oxygen in water in order to remove organic matter in wastewater. The aeration process has several types, one of which is using a tray aerator. Aerator can be done naturally by diffusion or mechanically. Natural aeration is the contact between water and air that occurs due to the natural movement of water. Some of the methods that are quite popularly used to increase natural aeration include using cascade aerator, waterfalls, as well as contour aerator. I take one example of processing using aeration process. It's wastewater treatment with active flush process. Biological wastewater treatment is carried out to reduce the BOD level of a waste so that it is safe discharged into the environment. The most commonly used process is the activated sludge process. This process consists of several stages, namely primary sedimentation, reaction in the aeration tank, secondary sedimentation, recirculation, and removal of residual sludge. The waste that enters the system is sedimented for deposition of impurity particles. Furthermore, biochemical reactions with the organic components of the sludge occur in the aeration reactor. Biomass is formed due to the presence of substrate in the mud. Biomass deposition occurs in secondary settling tank. The solid part in the tank is then circulated into the aeration tank to maintain the concentration of biomass in the reactor so that it affects the efficiency of the system. The residual sludge from this treatment is then directed to the sludge treatment plant. In addition to the process, there occurs nitrification and denitrification by microbes. Problems that often occur in the activated sludge process, including the phenomenon of bulking and foaming caused by filamentous bacteria in the aeration tank. Along with the development of technology, the secondary sedimentation process can be replaced by membrane ultrafiltration. Currently, the activated sludge process can be replaced by a membrane bioreactors. Some of the benefits of membrane bioreactors include better effluent production, more space required, less and less residual sludge is produced so that it is more efficient and the cleaning process is carried out less intensity. Aeration technique. This process is an attempt to increase the concentration of oxygen content in the water so that the oxidation process to change the form of cations goes well. In practice, there are two ways to add oxygen to water, namely, number one, incorporating air into water is the process of introducing pure air or oxygen into wastewater through a porous object or nozzle. The nozzle is placed in the center so that it will increase the contact speed of the air bubbles with the air, with the water, and the oxygen delivery process will run faster. Therefore, this nozzle is usually placed at the bottom of the aeration tank. The intake air becomes from the outside air, which is pumped into the water by the pressure pump. And number 2, forcing the water up to make contact with oxygen. There is a way of contacting water with oxygen by rotating a propeller that is placed on the surface of the wastewater. As a result of this rotation, the water will be lifted up and come into contact with the air. Number 3, this disperses water with air over a thin slab via a waterfall aerator or by mixing water with air bubbles. And the last, number 4, contacting water with air through a gradual process of falling, or you can call cascade cycling. Coagulation. Coagulation is the addition of chemicals to destabilize the electrostatic forces of non-suitable fluids. Chemicals typically have a positive charge which bind to the negatively charged particles in water, neutralizing them and allow them to come together to form a small clumps of particles called microflux. The coagulant is dispersed quickly and evenly to encode as many particle collisions as possible. Because this process relies on chemical reaction, several considerations must be made. Water temperature, for example, colder water usually slows coagulation and flocculation reactions, which may require more time to achieve optimal flux information. Extreme values of pH, high or low, will also interfere with the process. Coagulant effectiveness is highly dependent of pH. For some coagulants, alkalinity is a factor. Operators may need to raise out validity for coagulation to be effective when iron or aluminum coagulants that can consume alkalinity and depress pH when they are added to low alkalinity waters. Turbidity is also important. The lower the turbidity, the more difficult it is to form proper flux. The most common coagulant chemical is aluminum sulfate, commonly called alum, polyaluminum chloride, and iron salt such as ferric chloride and ferric sulfate are also used. They operate over a wider pH a wider pH range. Coagulant and flocculate aids are aided to improve binding, build stronger, more suitable flux, and effect flocculation by increasing flux. Coagulant aids include cationic polymers of lunch produced. Commonly used coagulant aids include cationic polymers. Polymer is a synthetic compound with high molecular weight and composed of repeating chemical units or monomers. Polymers may be polyelectrolytes, such as the water-soluble flocculant, water-insoluble ion exchange resin, or insoluble uncharged material. That's all of my resume. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.